Hi, everybody. Happy Monday. Welcome to week 4 of e-learning. The purpose of this video is just to give you kind of a general overview of the project that'll take place between today and tomorrow. Today being Monday, tomorrow being Tuesday. Yes, I do need to say the days out loud because I rarely know what day it is at this point. So if we were in class right now, we would be doing a whole big thing, kind of like the show Survivor, where we'd have different creatures and whose population lasts the longest. But we are virtual and we are going to make it work. So we are on Exponential Island right now. The purpose of this project is for you to be able to work with exponential functions, more specifically ones that involve exponential growth and exponential decay. So you'll see that there are two parts of the project where you'll be working with the growth equation, and the other part you'll be working with decay. So let's jump in, and hopefully you can see on my screen what we're going to be looking at. This is what's pushed out to you as well. Part 1, you need to create some type of creature. When I say create, that doesn't mean you need to draw and come up with it yourself, which you can. If you are artistic and you can draw and copy and paste in there, that would be amazing. However, if you are like me and have no art skills, you can copy and paste from Google. If you want to pick a bug, you want to pick an animal, you want to pick a human being. If this was me right now, I would pick my husband. That needs to go into this box here, okay? And then you are going to keep scrolling. Notice that as you move through the project, wherever you see yellow, whether it's a bright highlight of yellow or just like a faded yellow, you need to be putting in some type of text, number, etc. So that's kind of your cue, like, oh, I see yellow, I know I need to be doing something there. So your creature is going to be living on Exponential Island with the classmates' creatures as well. Your population is going to be growing exponentially every month. Now, I know a lot of the examples that we looked at in previous lessons, they were growing exponentially by year. This is a special island. This is Miss Levan's island. It's growing exponentially every month. All right, so to get started, notice I see that there are yellow boxes, aka I should be putting in text here. Step 1, name your creature. This is me. I'm going to say Scott Levan. Starting population and growth rate. You need to message me to get that. There are different populations, different growth rates for every single person in class. So to get your starting population, to get your growth rate, you need to message me for that. You can't do anything in the project without that. Once you have these two values, you need to put them into your exponential growth equation. Let's say that your starting population, I'm going to give you an example, was 500, okay? And your growth rate was 5%. I know that because it's 5%, we express that as a decimal, so it's going to be 0.05. Now, to put that into the equation, I'm going to have y equals, instead of a, I'm going to put in 500, because that's my starting population, that's my initial amount. Remember, though, for b, we're not going to put 0.05, it's going to be 1 plus whatever that rate is. So in my case, it'd be 1.05. And then this x value here, you can leave that, okay, as part of your equation, because that's going to change every time. Now, once you have that, you are going to go plug in a table of values for how your population would look from the starting point at month 0 all the way for a whole year. So at month 0, if this was my data, I would have 500. Sorry, that is microscopic. And then to figure out the rest of it, instead of x, I'm going to plug in a 1. And then for my next row, instead of an x, I'm going to plug in a 2. So x as the exponent in your equation really represents the number of months that are going through. So you're going to fill in that whole table. Now the graph part, this is mainly why I wanted to come on video to kind of explain and talk you through it. You have a few options for how you want to graph. You can use Desmos. So you could essentially just copy and paste that whole table and put it into Desmos. The only thing you need to be aware of is that you have to have labels for your x and y axis. Okay, so maybe you have like months and then population. You have to have a title and then you have to have all your data points. If you are not tech savvy, you could draw it on paper and then you could plug it in. So like you could draw it on paper. This is how I would do it. Draw on paper, take a picture of it on Schoology and message it to myself, and then copy paste it into the document. You can use the graph below if you want. So you could like plot points on here, put labels. That kind of seems like a lot. You could also use Google Sheets. So I'm even going to add that option for you now. So you could use Google Sheets with your table of values to create yourself a line graph, but I want a line graph. And you did that with the college project, so that should be pretty familiar too. Okay, and then you're done with exponential growth. Now, tragedy on Exponential Island, welcome to a deadly virus that has been discovered. Yikes. Your starting population is going to be the same as above, so let's say we still have my 500, but your decline rate, you need to get that from me again. So that's kind of like my checkpoints with you guys throughout the project. It kind of helps me to see where you are because when you send me the message to get your numbers, and like I have the whole list right here of what all your numbers are, your populations, that lets me know where you are. So let's say that my decline rate was 6%, and I know that I'm going to express 6% as a decimal of 0.06. When I'm entering my equation here, I'm going to start with my y equals, instead of a, I'm going to put in 500 because that's my initial amount. For b, though, this is different. Because it's decline, we're going to do 1 minus whatever that decline rate was. So 1 minus 6 hundredths here is going to be 0.94 94 hundredths. Oops, sorry. And then you'd also still have your exponent right there. And then you'll go through and you'll plug in your table of values here. Hopefully, if you're doing it right, your number should be decreasing as you go down. All y values should be rounded to the nearest whole number. You cannot have half of a creature, as much as you might think so in Fantasyland. You cannot have half of a beetle or like 3/4 of a bug that's no longer living. So you need to round them always to the nearest whole. Once your y value rounds to 0, so like let's say that it was in month 7, I was at like 0.3 of a creature, that rounds down to 0, you're done. Your population is extinct. You don't need to fill out the rest of the table here. And then I'd say it took 7 months until my population went extinct. Okay, and then you're going to do the same thing when you have your graph down here. Use your same options as above. If you don't use the graph that I have, you can just click through and delete it. So I think that's pretty much it. If you have questions about the project, message me. But good luck to you and your population, and I'll see you later.